All right, so we're fixing to start with a couple new formulas that are the double angle formula. So we're going to start by finding out what the double angle formula is. I'm not going to tell you. We're going to discover it. So I start with sine of 2 theta. Okay, well that's cool, but it doesn't tell me a whole lot. But what if I rewrote 2 theta to just be theta plus theta? Because that's what 2 theta is. So now I have a sum, right, of 2 angles. This is my alpha, this is my beta. Well, alpha and beta this time are the same thing. So using the sum and difference formula that we learned from section 2, this would be sine of alpha cosine of beta plus sine of beta cosine of alpha. Yeah, that was on the test yesterday. That's when you had to know.
Did you see my test?
I did see the score. I did see your score.
I don't know what it is. I don't want to know what it is.
So now I've got sine cosine plus sine cosine. Well, that's just 2 sine cosines. So the formula is here.
2 sine beta.
Questions there?
That's the double angles formula.
Double angle for sine.
2.
Sine 2 theta is 2 sine cosine.
Why does cosine just get added in?
Well, I remember we were short on time, and I told you I didn't have time to explain that. Y'all probably didn't care anyways. But if we got time today, I'll show you where this formula comes from. Alpha plus beta. I could write this. Probably as cosine of theta plus theta.
And then cosine plus sine.
So what was the formula for
Sine.
sum of cosine?
Cosine.
It's cosine of alpha, cosine of beta, minus opposite sign, sine of alpha, sine of beta.
It's on the second page.
Which is cosine squared of theta minus sine squared of theta.
Oh, we'll just write it down.
What page are we on?
Dude, just write these down. You need them.
This is the first one, very first one. It says prove sine of 2 theta and cosine of 2 theta.
Oh, that's what the squared little signs were yesterday on the test.
I'm so scared. What are we going to talk about? You okay with this?
No.
Ooh.
Well, I'm not done yet. Because actually, there are 3 different formulas for cosine of 2 theta. I just found one of them. But look at what the one formula reminds you of. Does this remind you of anything? I just get visions of Pythagorean identities.
Cosine squared plus sine squared equals tangent
Tangent
squared.
squared.
Right. So I know sine squared plus cosine squared equals 1. Is there any way I can manipulate this to make it say cosine squared minus sine squared? No, because if I move the sine squared over to make it negative, the cosine squared is still positive, but it's on the wrong side. And if I move it over, it becomes negative. So there's no way to move things to make it match this one. But what I can do is I could isolate cosine squared. Cosine squared is 1 minus sine squared. Yeah. So I could take this and plug it in for cosine squared, which would give me 1 minus sine squared. And there was already a minus sine squared, which means I have 2 sine squareds. This is the second formula for cosine of 2 theta. Yeah, this is still cosine of 2 theta. It could be cosine squared minus sine squared. Or it could be,
So like on the test when it says make
you just
it,
get to choose which one works best for you.
what about when it said make it to where it's like reduce it or something like that?
Yeah, that's what we're doing. Or, going back to the first one I found, what if I isolated for cosine squared? Well, that would say cosine squared, that's what I've already did in it. Scratch that. What if I isolated for sine squared? That would tell me sine squared equals 1 minus cosine squared. So I could take this and plug it in for sine squared, which would give me cosine squared minus sine squared, but sine squared is 1 minus cosine squared, which means if I distribute the negative, this becomes a cosine squared minus a 1 plus a cosine squared, which is 2 cosine squared minus 1. So here's your 3 formulas you need to know. They're at the top of the next page, right? Cosine of 2 theta equals cosine squared minus sine squared, or it could be 1 minus 2 sine squared, or it could be 2 cosine squared minus 1.
I like cosine squared minus sine squared.
Well, that's good. Thanks for picking your favorite.
Which one's yours? Hey.
So here's what you need to know, right? But hopefully we've done enough of these now. You can kind of understand how I'm proving them using the identities we already know. So, and then here's the one that's least used again. Tangent one, we're not going to take time to show
What
where it
about,
comes
like,
from.
cosecant one? On the test there was cosecant in there and stuff.
Yeah.
Yeah.
Yeah, we don't have a double angle cosecant formula. Guess I could make one. Cosecant's 1 over sine. So I just make this 1 over sine of 2 theta, which would be 1 over 2 sine theta cosine theta. Which means I could make that, if I want to move it up, 2 cosecant theta secant theta. But we don't use that. But I could still prove it using... So let's just dive right in. I don't want to go over the strategy. I just want to do it.
Yeah.
Example one.
Sometimes the best strategy is no strategy.
I heard that.
Sometimes I do on the test, I do strategy.
Probably not. That's probably not a good time to try that.
Wait, I have a question.
Oh, God. Well, not quite. This is not quite unit circle, but it's still the same thinking. We know tangent of theta is negative 3 over 4, and we know theta is in quadrant 2. What else do we know about tangent? We know tangent is the opposite over the adjacent. So if this triangle is happening in quadrant 2,
It's sine over cosine.
the opposite is 3, the adjacent is 4, which means
3, 4,
the hypotenuse is 5. It's a 3, 4, 5 Pythagorean triple. If you didn't know, you could have used the Pythagorean theorem to find it.
3.
But this is rotating theta, right? This is rotating theta because I'm finding tangent of theta. But what if I doubled this rotation? So let's just think about very quickly, just a thought experiment. This is not how you work this problem. This is just us thinking right now. If I doubled my rotation, where would I be?
Bing, bop, bam, bada, bop, boom. So you're
Fourth quadrant.
Maybe.
possibly. What is theta?
Exactly. Exactly. Theta is between 90 and 180. So if theta was 91, right, if it was right here, and I doubled it, I would be at 182, which would put me here. I could be in quadrant 3, right? Or what if theta was 150?
300.
300, which would put me in quadrant
4.
4. So it could be 3, it could be 4. If I go all the way to 179, right? I double that, that puts me at 358. I can't go any farther than quadrant 4. So I know doubling this angle will put me in either quadrant 3 or 4. How do I know which one it is? Well, I don't. I don't until I use those identities. I can't find theta. I mean, I could, but that's not the way we're going to do it. We're going to do it without finding theta. So it asks me to find sine of 2 theta, which means, hey, if you double this angle, what would be your ratio of the opposite over the adjacent? Well, another way I can find what that would be is I could just multiply 2 times sine of what theta already is times cosine of whatever theta already is. This is our new identity, right?
That's all right here.
Thanks. Sine of 2 theta is 2 times sine of this angle, cosine of that angle. So because I'm in the second quadrant, sine is positive. So what is sine of this angle?
6.
It's not 6. Sine is the opposite over the hypotenuse. So sine of the angle is 3 over 5. What's cosine of this angle?
4 over 5.
Close. I said close. Negative 4 over 5. Because I'm in quadrant 2, cosine is negative.
Oh. That makes sense.
It does, doesn't it? So now it's 2 times 3/5 times negative 4/5, which would be negative 24 over 25.
Wait.
Because I multiplied.
Okay.
2 times 3 is 6. 6 times 4 is 24. And then in the denominator, 5 and 5 is 25. You can put 2 over 1, multiply fractions. So did this help me know which quadrant I was in? Absolutely not. Because the sign was negative. It's negative in 3 and 4. All students take calculus. So I still don't really know. But once I find cosine of 2 theta, all students take calculus. If cosine is positive, I'm in quadrant 4. Cosine is negative, I'm in quadrant 3.
So we're in quadrant 3. This cosine was negative.
We don't know that. We don't know cosine was negative. We knew cosine was negative in quadrant 2, but I'm doubling that rotation. Remember, I was trying to give us a...
So we
I
got
did what we're
gotta
doing.
do cosine.
Yeah, now we got to find cosine of 2 theta.
I feel like we should probably use the cosine minus sine.
Really? I would use any of them but that one.
Well, they'll take my word.
wait, cosine squared?
You like which one?
2 sine squared.
1 minus 2 sine squared? Sounds good. You could use any of them. Don't get me wrong. But I don't like using the cosine minus sine one because I'll have to find the ratio of cosine and then square an ugly fraction. And then I have to find the ratio of sine and square that ugly fraction. And instead of squaring 2 fractions, I can just square 1 fraction.
And the one you already have.
Wait, which one do you like better? That one or 2 cosine squared minus 1?
I don't. That doesn't
It just
matter.
depends.
For this one, it wouldn't matter. It would depend on what I was given. I was given tangent. Well, none of them deal with tangent, so it really doesn't matter. So, back to, now I've got it in terms of my original rotation theta. So this would be 1 minus 2 times, what is sine of theta?
Minus 24.
It is not. That is sine of 2 theta. Sine of 2 theta is negative 24 over 25.
3 over 5.
Sine of theta is this rotation. It is 3 over 5, and it's positive because I'm in quadrant 2. So sine of theta is 3/5 squared. Right, because it's sine squared. So 3/5 squared would be 9 over 25. If I multiply that by 2, that's 18 over 25. So 1 minus 18 over 25 would be 7 over 25.
Wait, 1 minus 18?
Mm-hmm.
You know? How?
It's 25 over 25.
25 over 25 minus 18 over 25. Fractions. Fractions are hard.
Oh, yeah.
Fractions are so hard.
My bad.
Isn't it crazy?
My bad.
I told this to my other class, like 85% of the questions that you guys ask in trig is not the trig. It's how do you, wait, how'd you do that with fraction?
How? I get it. 25 over 25.
I need to multiply here.
18.
I agree. So I've got 1 minus 18 over 25. Now I'm subtracting a fraction. Well, if I've got one whole pizza
Oh, no,
and I cut it into 25 slices, that's the same thing as 1. So now I've got, I had 25.
I was taking one away instead of taking 18.
Well, why? One's at the front.
Oh,
Okay, that's even harder. Now that's like first grade subtraction.
That's what I was doing too. I was like, it should be negative 7. Because I was trying to minus 4.
So now, given this, I know what quadrant I'm in.
Oh, we're probably in 4.
We're in 4. So this triangle, when I rotated double, would move me to quadrant 4 with an adjacent side of 7, an opposite side of 24, and a hypotenuse of 25. This is an old classic 7, 24, 25 Pythagorean triple. Y'all have that one memorized? Maybe,
I
maybe
did.
not.
You told us to.
Did I say that one? Good. I didn't know if you remembered it though. I've told you lots of things to do that it's not apparent you did it.
Stuff that doesn't matter.
Now, for the last one, tangent of 2 theta. We could use that formula. You know that formula they gave us? Or I could just know.
2.
I know tangent of 2 theta is the opposite over the adjacent. And the opposite side is 24, negative 24.
It tells us that tangent theta is negative 3 over 4. Why don't we just square that?
No, that's not how it works. I'm not squaring the original ratio. I'm doubling how much I rotated. Give me a second. Give me 1 second. I'll show you. And because I'm in the 4th quadrant, all students take calculus. Tangent would be
Positive.
negative. This is negative 24 over 7. You just had a 50-50 chance. You just blew it.
Imagine a full day of trig.
Okay, here we go. Suppose A is an acute angle. Sine of A is 16 over 65. Cosine of A is negative 63 over 65.
Oh, so it's probably in the 4th quadrant.
I doubt it because in the 4th quadrant,
No. Let me try again. 2nd quadrant.
It's in the second.
it is in the 2nd quadrant. I agree. This has to be in the 2nd quadrant because sine is positive, cosine is negative. It's the only quadrant that happens in. So I'm going to draw into the 2nd quadrant. Can I fill out my triangle? Well, the opposite is 16. The adjacent is 63. The hypotenuse is 65. This is the old 16, 63, 65 Pythagorean triple.
I did not have that one.
I don't have that one either. Okay, but luckily I didn't have to. They just gave it to me. So thank them so much. Now, here's my triangle. Can we find sine of 2a? Well, sine of 2a, I'm going to be in either quadrant 3 or 4, right, for the same junk we talked about before. But I don't know where until I let the math play itself out. So what is sine of 2a? Well, it's 2 times sine A cosine A. So what is sine of A?
16, 65.
16 over 65. What is cosine of A?
Negative 63.
Yeah.
Negative 63
65.
over 65.
2 of them equals 32 over 65.
It's not asking for 2 of them, is it?
It's 2 of these. That's fine. So it's 32 over 65 times this. I can't do that. Hopefully a calculator person will appear.
Whoa.
If not, I guess I'll
Will you be our calculator person?
It appears I am. Oh, there's some over there. Some in the wild have appeared. Look, I do a lot of this math in my head. This ain't one of them. I don't have a clue what 65 squared is.
908.
Let me. You may try 65. No.
Yeah, try.
36,000 plus. I'm 36,000 plus 1,200. 36,000. 36,000 or 3,600? I'm going 36,000 plus 1,200 plus 25. Is it 37,225 is the denominator? That's not the denominator?
4,225.
It's what?
4,225.
Oh man, I'm way off.
It was 3,600.
It's 36. So it should have been.
No, it still wasn't. Because 3,600 plus 1,200 would be 4,008.
Well, see, I'm glad I didn't do it. What's the answer?
Negative 2016 over 4,225. That's one stupid problem.
Yeah, whatever. I don't care.
Negative 2016. That was a good old year.
No.
Yes, it was.
To find cosine of 2a.
Cosine of 2a, you gotta do cosine minus sine.
No. Let me think.
We could.
Cosine squared of theta minus 1.
Is that right? Is it 1 minus 2?
Minus 2 sine.
1 minus 2 sine?
We could do cosine squared, 2 cosine squared minus
Yeah,
1.
we can pick any of those. We can pick any of those from the double angle identity. I just picked the same one we did before. This would be 1 minus 2 times sine of theta was 16 over 65 squared.
Alright, so 2 is 16, 15.
You got to square 16 first, order of operation. So 256 times 2 would be 5.
Figure out parentheses, exponents.
That's right.
Multiplication.
You have this answer? You have this number?
Yeah.
What is it? I thought you were a calculator guy. I told you. Thank you. Okay, thanks.
3,713 over 4,225.
Positive?
Positive.
So, quadrant 4.
So quadrant 4. That's right.
What? Oh yeah, because it's called.
This cosine's positive.
What if it's quadrant 1?
Don't ever doubt
It's not because sine's negative. And I just showed you if you double an angle in the second quadrant, it can only be in the third or fourth. Just don't know which one it is.
Fourth quadrant, designated.
cosine.
All right, just looking right here.
Basketball.
If cosine squared of 29 minus sine squared of 29 equals cosine of A, then what's A? Well, this is what? Just think about this as cosine squared of x minus sine squared of x equals cosine of 2x, 2 theta, however you want to think about it. So to find A is double whatever these are. So what are these? 29. Well, so double it.
Wait. Could you just add them together?
Sounds good. That's not how it works, but
It ate all your paper, and after doing 9, because I was just gonna put mine in at the end of yours, and it just crunched it all up, so I had to power down the
Oh,
whole
gosh.
thing. So
I'm sorry.
you look like you have 9 complete sets, and then I don't know what
Parts of a,
Yes, I'm so sorry.
That's good.
Like the part you have to like pull down under the little panel, it just ate it all and shoved it under there. So I shut it down, and maybe it's okay now.
think you got it fixed?
I hope.
Okay,
I don't know.
I'm sorry.
I'm sorry.
Has that ever happened before?
Sometimes. The copy in there sucks.
Jack copied his hand yesterday, Mr. Hall's class.
That's nice. Right, same thing. Cosine squared of theta minus sine squared of theta would equal cosine of 2 theta. So I should double my theta. If I double 8x, I get,
Non X.
that's not, no,
64x.
no.
It's 60.
Double, not
Oh,
square.
16.
So you can just add them.
Well, it sounds good, buddy. Yeah, just add them. Yeah, double them. Just add them. That'll work.
Add it to it.
I mean, that has nothing to do with the formula, but that's fine.
How does it work both times though? We got mega lucky. It's not the formula.
And we could go use that formula, but I hate the formula. I think we'll have to use it though. I don't think I have any other option. Because I won't know what quadrant it's in if I don't. Okay, they didn't give me enough information.
Is this
Where's the
hardest
formula?
thing we're gonna do all year?
No.
Is this the hardest thing we've done?
I mean, what do you think? I don't think it is, but if
Me,
you,
it is.
okay.
It's probably because you didn't do the last two. I didn't either, but
It's so confusing. It's not
Tangent of 2a equals 2 times tangent of a over 1 minus tangent squared of a. That's straight from the formula. This is 2 times, what is tangent of a? 7 over 24 over 1 minus, what's tangent of a? 7 over. And then guess what you do? You plug that in. And you get 336 over 527. I mean, that's straight up plug into the formula. That one's no thought. Was good with that?
give me all.
Okay, so we're on page 5, bottom of page 5. These 3 formulas I've really rarely ever used. But I'll show you where one comes from, and you can kind of figure out where the rest of them are. They're all similar. So we just learned
I don't think we use that
on what? You don't use this one?
Not on 3.3.
You've already looked at point 3? Yeah. There's only one practice problem like it. So again, I very rarely use this.
The pancake breakfast in the morning. I understand that we're gonna have our football coaches here cooking pancakes for the pancake breakfast. So if you buy the ticket, please make sure you don't forget to come in the morning. I think they start serving at 6. 6 to 11, and get your pancakes. Thank you.
Buy a ticket.
When is it?
Tomorrow morning.
I can't make it tomorrow. Sorry.
You want to buy one anyways?
All right, so we've got this formula. I'm making sure I copied it down correctly. Cosine 2 theta equals 1 minus 2 sine squared. This is the second one of the double angle formulas. If I take this formula, I could isolate it for sine squared. Right, so just think about getting sine squared by itself. So I'm going to move this over here. I'm going to move this term over here, which will give me 2 sine squared theta equals 1 minus cosine of 2 theta. And now divide everything by 2. So I'm left with sine squared equals 1 minus cosine 2 theta over 2, which is that first reduction formula. So it's just kind of using the double angle formulas and isolating the squared term in each of them. Okay? But again, not something I don't know if I've ever used. And Chris said he didn't think he used it at all on the Canvas. So I don't think it's an example problem using one. So we've got sine cubed of 2x equals 1/2 sine of 2x times 1 minus cosine of 4x. And I may mess this up completely. But it's going to be using that formula we just looked at. Typically, when we work a problem like this is proving an identity. We pick one side and we try to manipulate it to make it look like the other side. We normally take the ugly side and try to make it look like the pretty side. Like 90% of the time, that's the way we're going to do that. But here, this is one of the rare exceptions. We're going to take the side that already looks good and ugly it up, I think. So, and again, I may completely butcher this, but we'll see. So if I have sine cubed of 2x, I could write that as sine squared of 2x times sine of 2x. I'm breaking the cubed apart to be a squared times the first power. So it's the same thing. Now, this is straight from our formula before. Sine of 2 theta, we can write as 2 sine cosine. Now, I don't want to do that. Dang it. This is the same mistake I made last time. Just leave it. Leave that. Because I need a sine of 2x in my final answer. And right here is that sine of 2x. Okay, so stop that, Cody. Stop it. Stop it. Stop it. Look at this. I don't want a sine squared. So I'm going to rewrite this portion. I'm going to rewrite sine squared of x. So using that reduction formula, sine squared of theta is equal to 1 minus cosine times 2 theta. This time theta is 2x over 2. And again, I'm just going to bring down the sine of 2x. Everybody follow that? And you see how I almost made a mistake? It can happen. Sometimes you don't really know where you're going. The reason that I stopped myself and I didn't rewrite sine of 2x, because I knew that would make it 2 sine of x cosine of x. But none of my answers are in terms of just x. They all are something times x in the argument. And so I remembered to stop it, which I didn't do in 6th period yesterday until I got lost in it for a second. Looking here, I've got cosine of 2 times 2x. I can write that as cosine of 4x. And now, because the left portion is over a monomial, we can break it apart to be 1/2 minus cosine of 4x over 2 times sine. Nope, I don't want to do it this way. This is allowed, what I did, but I'm looking at my final answer, right? I want to leave it as 1 minus cosine of 4x altogether. So let me change this slightly. I want to think about it as factoring a 1/2 out. So if I factor a 1/2 out, that's going to leave me with 1 minus cosine of 4x. I'm factoring a 1/2 out of this. And so you can see if I factor a 1/2 out, that leaves me with a 1. If I factor a 1/2 out of this, it's cosine of 4x. Just think about if I distributed this. This would be 1/2 minus cosine of 4x over 2, right, which is what I started with. Kind of an odd thing to factor out. And then we're going to bring down the sine of 2x. And we basically have this answer. We just have to rearrange it, right? Everything's being multiplied, so we can just multiply in any order we want to. So they put the 1/2 in the front, and then they multiply that by sine of 2x, and then they're multiplying all of that by 1 minus cosine of 4x. Of theta equals 1 minus cosine of 2 theta over 2. What they wanted me to do is find the next set of formulas, which is the half angle formulas, from this reduction formula. That's probably why they even showed you these, was to show you how you could get to the half angle formula. And so I may mess this up, but I think the way to do this is to use a U substitution. You guys, do you remember doing that in the section 1? Where like you had to factor, and it used to say sine of x, but then you rewrote it as U, so it made it easier to factor. So we can make U anything we want it to be that will help make this problem look nicer to us. So I'm going to let U be equal to 2 theta. Which means everywhere in my problem that I see a 2 theta, I'm going to write a U instead. Okay, well that's real helpful, Cody. There's only one 2 theta. But this still has a theta too. And so if U is equal to 2 theta, I wonder if I could find out what theta must be equal to.
1/2 U.
Thank you. If I isolated the theta here by dividing by 2, that tells me U over 2 is equal to theta. So here, instead of saying theta,
I was actually joking. I didn't think that was the right
I could say U over 2. And so,
I knew it was the right.
if U is my angle, now this is half of that angle. Right? Half angle formula. So how could I solve to get this half angle isolated? Well, right now it's being squared. What's the opposite of squaring something?
Square rooting it.
So if I square root something that's being squared, that will cancel. And I'm left with sine of U over 2 equals, and then I chose to take a square root over here, which means I have to account for the plus or minus possibility. Every time I make the square root, I account for plus or minus. The square root of 1 minus cosine U over 2, which is that top formula on the half angle. They use alphas instead of U's, right? But it's the same thing. Everybody see that, what I'm talking about on page 7, top of page 7. And so this process of finding the formula, you won't have to do, but now then we can use it. I'm not going to do it for the other two, but we could also do it for cosine. We could also do it for tangent, right? Just use the same process, doing a U substitution. So this tells me to find sine of 15 using a half angle formula. Now, there are other ways we could find sine of 15. We could use a sum and difference formula. If we did sine of 45 minus 30 and use that formula we learned about in section 2, we could find this answer. But because they want me to do a half angle formula, then that's what we will do. So how could I write 15 as some angle over 2? This angle would need to be 30. Because 30 over 2 is the same thing as 15. So I'm going to write this as sine of 30 over 2. Which means my alpha in the formula is 30. So this would be plus or minus, and we'll choose which one in just a second. 1 minus cosine of alpha, which was 30, over 2. Okay with this? What is cosine of 30? Yeah, radical 3 over 2.
Yeah.
We gotta get faster at those. All goes back to the unit circle.
I can draw it and do it.
Okay, good, good.
I can do it in my head, but it'd take.
I can Google it and do it.
I could do it.
So from here, I need to get a common denominator of the, or did you leave your answer like this? Did you leave it ugly? If you've already done this? Or have you already watched the video? It's okay. See if they left that ugly like that. Or if they, no, that's what I figured. So we don't like radicals inside fractions inside. That's just ugly, right? That's awful. Now, my open math will probably take this if you just type it in like this. But I'm going to go through the process of how to simplify that. I would need a common denominator in the numerator. So this becomes 2 over 2 minus radical 3 over 2, which means I have 2 minus radical 3 over 2. That's the numerator. And this is all over 2 over 1. And it's all under the radical. Oh my gosh. How disgusting. Now, I've got to write this like I'm a 5th grader. So I'm going to multiply by the reciprocal. So this becomes 2 minus radical 3 all over 4. And remember, this is all underneath the radical. So this is the square root of 2 minus radical 3 all over 4. But I know what the square root of 4 is. The square root of 4 is 2. So this is plus or minus the square root of 2 minus radical 3 over 2. Now my radical is not over the entire fraction, right? My radical is only in the numerator, which means I've rationalized the denominator, which was my goal. Now the last thing I have to do is decide if it's the positive or the negative. Well, look back at what my angle is. My angle is 15. 15 should be positive because we're taking sine of 15 in the first quadrant. It should be positive. And so 2, radical 3 is like 1 point something. Okay? It's 1 point something. So 2 minus 1 point something is positive. Square root of that is positive, so I want this to be positive. So this would be positive radical 2 minus radical 3 all over 2. Is that the way they left it?
Yeah.
Good. That's the way I would leave it. I was making sure we didn't need to, because that would just be an endless disaster, I think, if we multiplied by the conjugate to get rid of that original radical. Then the radical would be in the denominator, and I'd have to rationalize. So I could probably keep going to make it look prettier a little. But
That was
So-
impossible.
it's not. I would start by finding the missing side of my triangle, because I might need it. So tangent is 8 over 15 in quadrant 3. So here's my angle alpha.
Oh, yeah, we learned about that.
Opposite is 8. The adjacent is 15. So this is the classic. 8, 15, 17. I think that's right. Pythagorean triple. If it's not, don't check me. 225 plus 64 would be 296.
Yeah.
296 is 17 because 256 is 16. Represent. Okay, so I'm always repping a 256.
16 squared.
I'm doing my perfect squares. See? Oh, I erased it. I did this in second period for Algebra 1. I always write out the perfect squares of 256, and then I wrote represent beside it, but I guess I erased it. It's a shame. So, there's my triangle for alpha. Well, what if I need to find sine of alpha over 2?
Is it called U?
Well, I'm going to use the formula, which would be plus or minus the square root of 1 minus cosine alpha over 2. But I know what cosine of alpha is. Cosine of alpha is negative 15 over 17. Because I'm in quadrant 3, and in the third quadrant, cosine is negative. Yeah, just double check me, Chris, because I could make a mistake at any point in this. This is not some of my favorite stuff. So this is negative 15 over 17, but there was already a minus in the formula, which means I could write this as plus over 2. Do they rationalize this? Or do they leave it as a 2 on bottom, radical 2?
They left it.
Or is the 2 outside the radical?
I think they left it. Yeah, they left it.
They just have to choose if it's positive or negative.
Yeah.
Oh, gosh. Okay. So, let's think about this. I don't know how they explain it. They may explain it differently. And if they did, and if you remember, chime in. Here's my thought process. I don't really know what alpha is, but it put me in quadrant 3, which means it's between 180 and 270. Has to be between 180 and 270. Okay? Well, if I half 180, that puts me at 90. Right? And I know it's not exactly 180. It has to be a little bit more than 181. So halving that's just a little bit more than 90, which would put me in quadrant 2. The biggest this angle could get is 270. If I half 270, that is 135, which would still put me in quadrant 2. So no matter what, halving this angle puts me in quadrant 2. Which means if I'm in quadrant 2, all students take calculus, means that the sign I need to choose is the positive one. Because this sign, S-I-N-E, is positive in the second quadrant.
Because it's positive.
Is that familiar? Does that sound like how they did it? Or did they do something? Or do you remember?
Pretty much.
Okay.
Chris knows that.
He's already watched it.
Watch the video.
Yes.
Chris is a good boy.
Some people are like that.
He messes with that, so.
This is one of those, I should have probably looked at this lesson before I just started teaching it. Because this is some of my least favorite. Choosing the positive or negative. And I know how I can reason through it, but there's probably a better way I could teach it. And I probably need to study that. Did that make good enough sense? All of that explanation was just how I choose this as positive. That was it. All right, if I had to find cosine of alpha over 2, do you guys want to try it? Or do you want me to do it? I'm just going to, I promise, I'm just going to look at the formula on page 7. You're going to get this formula. You don't have to memorize this formula. This is given to you. And I'm just looking at it.
That's my laughable video.
And I'm just going to do exactly what it tells me to do. So cosine of alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. Hello? Hey. I mean, if they want, I mean, whatever.
It just works.
Yeah. We'll figure out something. Okay. All right. Love you. Okay. Did y'all go from here? Did y'all do this without me? All I gotta do is find cosine of alpha. Well, this is still alpha. It's still this triangle. Right? It's still the original setup from here. So cosine of that alpha is still negative 15 over 17. Because I'm in quadrant 3. Cosine is negative. So this becomes 1 minus 15 over 17 over 2, all under the square root. And then I have to choose if it's positive or negative. Well, if I half this angle, where am I going to be? Halving something in the third quadrant will put me in the second quadrant. And in the second quadrant, cosine is negative, which means this needs to be negative. I have tangent of alpha over 2. Guess what I'm going to do? I'm going to look right at this formula. There's 3 of them. I don't care which one you pick, but I probably wouldn't pick the first one. If it were me. I would probably pick the last one. Because the denominator is a monomial. Not that it even matters. Right? They all are the same number. And if we leave it in their ugly form, who cares? Which one did they choose? Chris? Did you write this one down?
The first one.
They did choose the first one?
Yeah.
I would never choose that one. Because it's a... But you can. That's fine. There's nothing wrong with any of them. I'm choosing the last one. This would be 1 minus... What is cosine of alpha? This is still my alpha. I'm still finding cosine of this alpha. 15 over 17. Negative because I'm in quadrant 3. So negative 15 over 17. So there was a negative in the formula, which means this becomes positive 15 over 17 over... What is sine of alpha? Negative 8 over 17. All right, in quadrant 3. So, again, my open math will probably just take this. But I'm going to pretty it up a little bit. I just can't take this. So, I'm going to get a common denominator of the numerator. So this is 17 over 17 plus 15 over 17, which is 32 over 17. That's my numerator. So I have 32 over 17 times negative 17 over 8. Right? This was my numerator. And so I divided by this fraction, which means I multiplied by the reciprocal. Again, go back to 5th grade every time. Now when I'm multiplying, I can cross reduce. So these 17s will reduce to a 1 and a 1. 32 divided by 8, that is 4. And then don't forget the negative. So it should be negative 4. Did they get all the way down to negative 4, Chris, or did they leave it at something uglier?
I think they got negative 4.
I just imagine all the rationalizing I'd have to do of radicals to get to.
Yeah, I did negative 4.
So this proves they used the first formula and got negative 4. I used the last formula and got negative 4. No matter which one you choose, If you simplify correctly, you can get the right answer. I just think this one's easier because the radicals are gone. I don't want to deal with them. So this is factoring. Formulas. So if I've got cosine squared of 4x, it looks like I can write that as 1 plus cosine of 2 times theta. This time theta is 4x all over 2. 1 plus cosine of 8x over 2. And I hope that's all we have to do. I hope so.
I think it is, 'cause
I mean, we can break 8x apart using the sum and difference or a double angle.
yeah, that's all you have to.
Okay. If you click the answer key, is that what it shows? Because there's different forms for all these.
Yeah.
Okay. So that is what they're looking for. So we'll show you one. So it tells me we're going to get these formulas from the sum and difference identities for cosine. If we add the two equations, we get. So I'm just thinking here, if I've got sum and difference of cosine, so I'm writing them down. Cosine of alpha plus beta equals cosine alpha, cosine beta, minus sine alpha, sine beta. And the other one was cosine of alpha minus beta equals cosine alpha, cosine beta, plus sine alpha, sine beta. So, think about this as an equation. This is the exact same thing as this. That's why the equal sign means. They're the same. And this is the exact same thing as this. Right? They're the same thing. So, let me just give you an example here. If I had x plus 3 equaled a half. I can keep this thing balanced as long as I do the same thing to both sides. That's the whole point of an equal symbol. Anything I do to one side, I can do to the other. So I could subtract 3 from this side. And the way we're used to doing math is we say, if I subtract 3 here, I subtract 3 here, and all is happy. But what if I decided not to subtract 3, I decided to subtract 6 halves over here? Oh no, I broke math. Is this doing the same thing to both sides? This is just a different form. It's still subtracting 3, but it looks different. So what we're going to do, we're going to take this equation, because these things are equal, and we're going to add cosine of alpha minus beta on both sides. On the left side, I'm going to add cosine of alpha minus beta. On the right side, I want to add cosine of alpha minus beta. But this is cosine of alpha minus beta. It's the same thing. So I'm going to add this to this side and add this to this side. But it's still balanced because these are the same thing. Just like this is the same thing. Does that make some sense? Okay. So if I add this, right, forget the equal to symbol between it, just pretend like we're adding this to both sides. That would give me cosine of alpha plus beta plus cosine of alpha minus beta equals cosine alpha, cosine beta minus sine alpha, sine beta, slide over, plus cosine alpha, cosine beta plus sine alpha, sine beta. I literally just wrote all 4 of those terms. Can y'all see that good enough? I know it's getting kind of squished. So now, I can't do anything with this. These are not like terms. But all of these have just alphas and betas. as their arguments. So is there any that are exactly alike? I've got cosine alpha, cosine beta, cosine alpha, cosine beta. If I combine those, that's going to give me 2 cosine alpha, cosine beta. Does that make good sense to everybody? Now I've got a negative sine alpha sine beta and a positive sine alpha sine beta. They cancel. This is like a negative x and a positive x. They just completely cancel each other out. Which means this is equal to cosine of alpha plus beta plus cosine of alpha minus beta. And now just looking at the formula, you see we want to get cosine alpha, cosine beta isolated. Well, right now that's being multiplied by 2. Which means I'm going to divide by 2. Well, if I divide all of this by 2, that's the same thing as writing it as 1/2 times all of that. Right? Dividing by 2 is multiplying by 1/2. And so cosine of alpha, cosine of beta, is equal to 1/2 cosine alpha plus beta plus cosine alpha minus beta, which is the first one. Is that enough to just trust me on the other 3? And say, yeah, we got it. We follow the process. We could keep doing this to derive the other 3. Somebody say something? Okay. Why did I pick the third one? Because it's sine times sine. And this is sine times sine. So, using this formula, what's really different between this and this? So like 52.5 is my alpha, right? 97.5 is my beta. There's a 2. That's the thing that's different. So if I want the formula to look exactly like this, then I would multiply by 2 right here. To keep it balanced, I would need to also multiply by 2 over there. This essentially just cancels the half. So now the left side is 2 times sine alpha sine beta. That's going to be equal to cosine of alpha minus beta. But what is alpha? 52.5 minus what is beta? 97.5 minus cosine. What is alpha? 52.5 plus beta? 97.5. It's just straight plugging in after we fix that little weird thing with the 2. So now, because this is being subtracted in the argument, I can simplify that. So what is 52.5 minus 97.5? It's going to be negative 45. Hey, I know that angle. Minus cosine. What's 52.5 plus 97.5? It's 150. Hey, I know that angle. What is cosine of negative 45? Negative 45 puts me in the fourth quadrant. In the fourth quadrant, cosine is positive. Cosine's adjacent over hypotenuse. It's radical 2 over 2. Minus, what's cosine of 150? 150 puts me in quadrant 2. It's a negative in quadrant 2. and it has a reference angle of 30. So I'm basically taking cosine of 30, which is radical 3 over 2. And this is minus negative radical 3 over 2, which I can write as positive. Which means my answer should be radical 2 plus radical 3 over 2. Right? We could write this common denominator. We could write this as radical 2 plus radical 3 all over 2. Which means, what's A? 3. It's the whole point is finding what A is. I got the answer to be exactly the right form, and now I can find the A value. Must be 3. Because that's what's missing. What are our thoughts? So let's try to get through this one, and then we'll call it quits. So when I look, I've got cosine times cosine. So which formula from the product sum do we think we should use? Probably the one that's cosine times cosine, which is the first one. Oh, here we go, this funny business again. What's different between this and this? There's a 2.
So that's good.
It is a little bit of a good thing, which means if I multiply this by 2, I would need to multiply the other side by 2, which makes those cancel. Okay. Which means I could rewrite this as cosine of, so this is my alpha, this is my beta. So it's cosine of 7x over 2 minus beta, 3x over 2.
Which is just 4x.
Right, we'll get that in a second. Plus cosine of alpha, 7x over 2, plus beta, 3x over 2. So this is 4x over 2 plus 10x over 2, which is 2x and 5x.
That's the answer? I already got that one right.
What?
The thing people, did anybody want to, okay, people are still writing. I went too fast. My apologies, my apologies, my apologies. The thing people mess up on these is they then try to make this 7x. Right? They just think we're combining stuff. Cosine of 2x plus cosine of 5x is cosine of 7x. That's not how it works. We can't put them together unless they're the exact same arguments. And then we would just combine the coefficients, right? 1 and 1 is 2. The reason I can do math in here like that is because it's already in the argument. This is in the parentheses.
If it was cosine 2x plus cosine 2x, you could write 2 cosine 2x.
That's right. That's the
That's
only
not
way you
what
can
we
combine
I-
separate
Yeah, it's
cosines.
cosine 4x.
No.
Huh? No.
No.
No. No. Sine of x plus sine of x is not sine of 2x. That's 2 sines of x.
I think I made perpetual motion.
That was a terrible screenshot. The last formula, cosine times sine. So this is the formula I'm going to use for this situation. Which means I can treat 37.5 as my alpha, 7.5 is my beta. And I'm just going to plug directly into the formula. So this becomes 1/2 times sine of alpha, which was 37.5, plus beta, which was 7.5, minus sine of alpha, 37.5, minus beta, 7.5. Like that. That's directly plugging in alpha and beta. Now my angles I can simplify those because it's in parentheses. So 37.5 plus 7.5 is 45. Minus sine 37.5 minus 7.5 is 30.
Now you gotta go by half.
Sine of 45 is radical 2 over 2. Sine of 30 is a half. And this is being multiplied by a half. Right? These already have a common denominator, right? Subtracting fractions. So I can write that as a single fraction. Radical 2 minus 1 over 2 times a half. And then when I multiply fractions, I multiply straight across. So 1 times radical 2 minus 1 is radical 2 minus 1. 2 times 2 is 4. So my answer here should be radical 2 minus 1 over 4. And I'm having to make it match this, which means they really want me to identify what is the A value, what is the B value. Well, A is what's underneath the radical, it's 2. B is the whole number being subtracted already, so it's 1.
Hey.
Here it tells me to write the following difference of signs expressions as a product. So this was a difference, write it as a product. Some people look at this and think that they can combine these like they are. You can't because they are different angles. Right? You can only combine if they're the exact same trig function, the exact same angle. So there's really nothing I can do mathematically to simplify this without one of those formulas. So if I'm looking at sine minus sine, that would be the second formula.
Hey.
You picked the right one?
Uh-huh.
All right. Celebration. This is my alpha. This is my beta.
Excuse me, teachers and students, this is very important. Because of our little fiasco that we've got with a water fountain upstairs in a 2-story building,
Griggs class.
some of the water in this building may be off. So students, before you use the bathroom,
Flush it.
check the water in the sink. If
Just
the
flush
water
it.
in the sink is not running, you need to come up here to the 5th and 6th grade hallway to the bathroom, okay? Please do not use the toilets if the water is not running. Thank you.
That'll be great for a video. So okay, me just plugging in alphas and betas. Now combine my like terms. Especially what's in parentheses, right, as my angle. So what's 4 pi minus 2 pi? 2 pi. What's 2 pi divided by 2? It's not pi. I'm an idiot. 4 theta minus 2 theta is 2 theta. 2 theta over 2 is theta.
Oh, that's
I was
about
saying pi.
40 and 20.
It's not 40 and 20. It's 4 theta and 2 theta. Or 4 pi and 2 pi if you're me. You just make up a Greek letter and go with it.
4 alpha.
Next I've got cosine. 4 theta plus 2 theta is 6 theta. 6 theta over 2 is 3 theta. So that's really kind of ugly looking, right? With this still being...
That's just-
But did I take something that was a difference and write it as a product?
Yes.
Then I'm done.
Hey, hey.
This would have helped me out so much.
So we get cosine of 15 minus cosine of 75. So I'm going to choose the third formula. Which means 15 is my alpha, 75 is my beta, So I'm going to have -2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. Simplify my angles. This becomes 90 over 2, which is 45. This becomes -60 over 2, which is -30. Everybody with me? Now what is sine of 45? Radical 2 over 2. What's sine of -30? -1/2. Has to be multiplied by -2. -2 times -1/2. Those completely cancel. That's 1. 1 times radical 2 over 2 is radical 2 over 2. Yeah, that's what we all think. Right, when I look at this, simplify cosine of 7 omega plus 5 omega all over sine of 7 omega minus sine of 5 omega.
It's gotta be a W, right?
That's the omega, yeah. Omega. We can call it W. Is it a W? No, it's too squiggly. That's definitely an omega. I think it's a W.
Fancy W.
The problem that I have with this problem is it's a division problem, but I hate dividing binomials. Dividing by binomials. It just makes it, it's just ugly. But if I could rewrite this binomial as a product of something being multiplied, then it would become a monomial. And I'm going to do the same thing to the numerator and see if there's anything I can simplify. Because if everything's being multiplied, I can start crossing out and reducing. But I can't do that here because binomials, not monomials. So here we go. We'll start with the numerator. Cosine of 7 omega plus cosine of 5 omega. Cosine plus cosine is the last formula. So this becomes 2 times cosine of 7 omega plus 5 omega is 12 omega. Over 2 is 6 omega. Am I doing too much at once? Is everybody okay with that?
Wait. Yeah, well.
I'm plugging this into this formula. Do you have, and you get it. So you have to look at this formula maybe. But it's 2 times cosine of alpha plus beta over 2. So all I did was I said, this is my alpha, this is my beta. So 7 omega plus 5 omega is 12 omega over 2, which was 6 omega. I'm just trying to shorten up my steps because I'm running out of space for this problem. It's going to take a lot of steps. Now the next part of this is cosine of alpha minus beta. So that would be 7 omega minus 5 omega, which is 2 omega over 2, which leaves me with just omega. So the numerator can be written as 2 cosine 6 omega cosine omega, which is a monomial, one term, much nicer to do math with. Now we want to do the same thing with the denominator. The denominator is sine minus sine, so I'm going to use the second formula here. So it becomes 2 times sine of alpha minus beta. That would be 7 omega minus 5 omega, which is 2 omega, over 2, which is just omega, cosine of alpha plus beta. That would be 7 omega plus 5 omega, which is 12 omega, over 2, 6 omega. Now, it's a monomial. Now, all of the reducing I can do because they're one term instead of two terms. Everybody sees the difference. I know this looks longer, But this is a single term because there's no plus or minus between it. Where this was two terms. So that's why I can just cross out the 2's,
Ooh, cosine 6.
cross out the cosine of 6 omegas, and now I'm left with cosine omega over sine omega, which is
Tangent.
cotangent omega. Tangent is sine over cosine. Cosine over sine would be cotangent.
Cotangent omega.
Cotangent
Why
omega.
not Omega on the test.
Just a
Probably be a drop down if you have to use an omega. Or you're going to have to change out your keyboard. No, just don't do that. There'd be a drop down button. All right. I'm going to go ahead and start working this one. This would be 2 sine of 15.4 minus 3.6. That would be 11.8 a over 2, which would be 5.9a. I guess that's an alpha. No, that's just an A. That's not an alpha. Weird. Why would they do that? I don't know. Cosine of alpha plus beta, that would be 15.4 plus 3.6, which is 19a over 2, which we could leave as 19 over 2, or because I'm doing decimals, 9.5a.
And bingo, we're done.
And that's it. We wrote the sum as a product.
I think that's the first time I've been able to do by myself. Since after
I think this is easier because you get all the formulas.
It makes it,
feels good.
like, it's some weird stuff, and the fractions are harder. Like, you're going to have to know how to do the fractions. This one, just as I look at it, I'm already thinking, I don't like this.
Can you go back to the answer? wanna
I
see
can.
what they did.
It's a mono.
So this one here is product to sum. So I'm going back to the original formulas. So do I have one that's cosine times sine?
Do we get those ones?
Yep, you do. Is the bottom one. Back to page 1 from this section, right? I'm going from product to sum instead of sum to product. These are just like reversed of each other. I didn't show y'all that. We don't care. Let's just use the formula.
Cosine.
So
Whoa.
what's different about this and this?
Got a
Coefficient.
14 out in front of it.
This has got a 14 out in front. So to use this formula,
Do we have these 14?
I would need to multiply both sides by 14. So I'd multiply by 14 over here, and I'm going to multiply by 14 here. 14 times a half is 7. So I'm going to have 7 sine of alpha plus beta minus sine of alpha minus beta. There's a couple of different ways you can do that, but I think that's the easiest. So now 31x is my alpha, 23x is my beta. 7 times sine of 31x plus 23x minus sine of 31x minus 23x, which is 7 sine of 54x minus sine of 8x. And then, well, or these sentences, and I'll try to put it in my words. See if I like theirs or if I want to change it. Trigonometric equations are, as the name implies, equations that involve trig functions. Similar in many ways to solving polynomial equations or rational equations, only specific values of the variable will be solutions, if there are solutions at all. Often we will solve a trig equation over a specified interval. However, just as often, we'll be asked to find all the possible solutions. And as the trigonometric functions are periodic, solutions are repeated within each period. In other words, trig equations may also have an infinite number of solutions. So, what they're saying is, if I tell you, this kind of goes back to when we're talking about inverse trig functions. If I tell you sine of some angle equals radical 2 over 2, what is the angle?
It could be 45.
45 degrees.
Yeah.
Or
135.
135. Because it's in the second quadrant, and sine is positive in the second quadrant. Or 405 degrees. Which is what? A full 360 plus another 45. Or, you following where I'm going here? 495. Or Isn't that right? Doesn't feel right.
Yes.
67, 20, 720 plus 135. I think it's right. I go the other direction too, right? I could go negative. I can keep doing this. The key is, like, this one to this one is 360 apart, a full revolution. And from here to here is a full revolution. And from here to here is a full revolution. So if I wanted to write the answers, there really are two answers here. It could be, I'm going to do it in degrees. It could be 45 degrees plus 360 times k degrees, where k is any whole number. So if I did one extra revolution, that's fine. Or 2 revolutions, or 3 revolutions, or 4, but it has to be a whole number. Right? This takes care of this one, and this one, and this one, and the next one, every other one. Even going this direction, it would take care of every other one. Right? Because k could be negative. So really k could be an integer. I said whole number. I should have said integer. Positive or negative. Whole number. Or it could be 135 plus 360k. Those are the two answers. But those two answers make up an infinite number of answers. Right? I should write where k is any integer. Now what's different about my answers versus their answer? Can you relate the two? This is 2 pi times k instead of 360k, because this is in radians. So I could have written this as pi over 4 plus 2 pi k, which they just normally rearrange that. Instead of saying 2 pi k, they say 2k pi. It just sounds better than 2 pi k. Is the only reason. There's no... Huh?
Is it kappa?
It's not a Greek letter. That's just a k.
Oh.
It's not an angle.
I thought it was kappa.
2 kappa.
Let's just call it kappa. That sounds good. If this one's a kappa, I always called it a k. So I'll blame Mr. Camp because he probably called it a k. That's probably why I call it a k. We probably need to get rid of kappa because I don't know.
Who's the kappa who believed that in Oxford University, Brad?
So here's what I'm thinking. In one full revolution, how many correct answers are there? How many times would cosine of theta be a half?
4.
Would not be 4, because in 2 of the quadrants it's negative. In 2 of the quadrants it's positive. So there's 2 times it'll be exactly a half. What 2 quadrants am I looking for? All students take calculus. I'm looking in
The first
1 and 4. Yes, all in calculus.
calculus.
Cosine is a ratio of the adjacent over the hypotenuse, which means if my adjacent side is 1, the hypotenuse is 2, this angle would have to be 60.
Oh yeah, cause the long.
Gosh. It's a 30, 60, 90. Well, let's do this answer in radians, because I think it's going to want radians if it doesn't specify. Okay? So 60 degrees would be pi over 3. And then how often would this come back and be an answer? Every time I go 2 pi around. So this would be plus 2 pi times k, or 2k pi. I'm just going to write it like 2 pi k right now because I think it makes more sense to us. But again, 2k pi is the way they normally write this. The other place this would happen would be if I rotated here originally, which would be a rotation of 5 pi over 3. That's a 60-degree reference angle in the 4th quadrant. And this repeats itself every 2 pi. So it would be plus 2 pi k, or 2k pi.
Sigma boy.
We good with that? These are my 2 solutions. Why is this not being restricted to just a single solution? Because it didn't start as an inverse, right? If we put the inverse cosine of a half, then I know I'm only looking at the first quadrant. But it didn't start as an inverse cosine. It started as a regular cosine. So kind of like whenever we choose to take a square root, we have to do plus or minus. If we choose to take an inverse cosine of both sides, we have to account for all possibilities because they didn't start with an inverse cosine.
That's so sick.
So these are all the possibilities that could happen. You guys want to try the next one? Can y'all answer that without me? And then we'll stop right there. Oh, and tomorrow y'all better be ready to factor.
Oh, I would love to fall.
I didn't say full. And we're not having any leftovers. Is that not what you do to leftovers?
Full them?
You full the leftovers.
No, I
Put them in the fridge?
Baggy.
Huh?
That's,
Oh. That's, never mind. I'm recording. I better not say that. Huh? Sine of t is a half. So what's t?
45.
Pi over 6 plus 2k pi, 2 pi k. And second quadrant, sorry. That's right.
why are they all 2 pi k?
Because it's 2 pi before we get back to our answer.
That's like.
And they're not always going to be 2 pi k, just so you... Hey, you going to like this? What do you think would be 2 pi k?
A circle.
Sine, cosine, secant, cosecant.
Yeah.
But how often do tangent and cotangent repeat themselves?
Every other.
Every pi, because they have a period of pi. Yeah, and there'll just be one answer
So it'd be pi.
that'll repeat every pi k. Because it repeats itself every pi. Instead of 2 pi. Yes, tangent and cotangent is less. 3.4 Canvas, number 5. It tells me to use the sum to product formula. Sweet. So I gave away my 3.4 to Raphael because he lost all his notes. So I don't have the sum to product formula right in front of me. If somebody can.
Sum to product formulas.
Yep, that's the one I'm looking for. Give me the sine plus sine, the first one. Here, I'll take a picture. Thanks.
3.5 day to day.
All right, so I'm using this formula. Everything's crooked because I'm not taking pictures straight on, so just deal with it. Okay? So this is my alpha. This is my beta. So plugging into the formula, I've got 2 times sine of alpha plus beta over 2 cosine of alpha minus beta over 2. All right, simplifying here, this is sine of 60 over 2, which is sine of 30. Then I've got cosine of 22 over 2, which is 11. You follow what I'm doing so far?
Okay, wait. So that's 60 divided by 2, and then that's, the other one's 22 divided by 2, so that's where we got 30 or less.
I know sine of 30. 1/2. So I've got 1/2 times 2 times cosine of 11. 2 times 1/2 is 1. So I think my answer is cosine of 11 degrees. Does it take that? If it doesn't, you may have to use your calculator. Oh, A equals. Oh, sorry. I need to read the rest of the question. So the answer is cosine of 11. But if you look back at the question says, I want to write it as sine of some angle. So right now the answer is cosine of 11. But if I want to write it as sine of an angle, what would the angle need to be? Well, this is the dumb identities that were at the end of section 2. Convert co-function identities. So what am you supposed to have memorized? Converting from sine to cosine and cosine to sine, we just do 90 minus the angle. So cosine of 11 is equal to sine of 90 minus 11, which would mean 79 is the answer. Because it doesn't want you to put sine. It just wants you to put the angle.
Okay, it's the alpha.
Yeah, and it just asks, what is the alpha?
If it would have said, what is the beta, it would have been 11.
Should have read the question.
Right.
Huh?
If it would have said, what is the beta, it would have been 11, right?
No.
Oh.
It tells me the answer has to be sine of some angle. And so what is that angle?
Oh, okay.
So I originally found the answer cosine of some angle.
Okay.
It didn't like that. So I had to convert from cosine to sine using the co-function identity. Those are my least favorite ones. That's why I can barely remember the name of it. But they're easy. It's just, that's why I don't like them, I guess. I don't know. So we were introducing the idea of, if I don't know what the angle is and I have to give every possible angle for sine, cosine, secant, and cosecant, every angle will repeat itself every 2 pi, right? And so there's an infinite number of answers that are all spaced 2 pi apart. Right here, this question tells me
Question before you start. Where are we at?
page 2 of section 5. Sorry, thanks. Everybody else?
Okay.
Colin. Say something. I just printed all these off for you. You know once I get started, it's over. Like, I just get in a total trance. Let me get that. Yeah. Okay. So this one is kind of funny because it says find every solution, but I only want the ones between 0 and 2 pi. Well, then that's not every solution, but whatever. So we have to give every possible answer between 0 and 2 pi, which just is one revolution around. Now, what makes this different from what I'm used to seeing? There's a 2 in front of the sign. If only I could just do like algebra and get the sign by itself. Oh, just divide by 2? As long as I do it to both sides. That's fine. You could? That's what I'm going to do. So this says sine of the angle has to equal negative radical 3 over 2. Hey, I know that ratio. Where the opposite is radical 3, the hypotenuse is 2, this would be a 60-degree reference angle. Another important characteristic, though, is that this is negative. Well, because I'm looking at sine, and all students take calculus, there should be answers in both the third and the fourth quadrants. So what is a 60-degree reference angle in the fourth or in the third quadrant? That would be 240 degrees, but we're in radians, so that's 4 pi over 3 radians would be an answer. And then I need a 60-degree reference angle in the fourth quadrant, because that's the other place this could happen. So that would be 300 degrees, which is 5 pi over 3. And that's all of the solutions between 0 and 2 pi. If they didn't have this line, the answers would be 4 pi over 3 plus 2k pi and 5 pi over 3 plus 2k pi. But because it restricts me to only being between 0 and 2 pi, that's all I have to list. I'm told to find cosine of what angle gives me negative 0.45. So I'm looking, how much did I rotate to get negative 0.45? Is this a ratio you're familiar with?
No.
The adjacent is 0.45, the hypotenuse is 1. I have no idea. I've never seen that. So how could I find the angle given the ratio of sides? When I'm looking for the angle. Hey, you need a calculator. How do you find an angle given a ratio?
Just put sine of that number.
Okay, that's fine. Let's be very algebraic then. Let's just be very algebraic. I need to know how much I rotated. I need to know x. But x is not by itself because I'm taking cosine. You divide by cosine? Is the cosine multiplying the x?
Yeah.
It's not.
No, it's
What? I am taking cosine of x. It's not multiplying.
The inverse.
So I need to undo cosine, which is the inverse cosine. And remember, we take inverse cosines of ratios, and that gives us angles. We take regular cosine of angles to find ratios.
So just cosine inverse of.
So the inverse cosine of negative 0.45, make sure you are in radians. Because it's saying here between 0 and 2 pi.
I think I'm in Spanish.
Muy bien.
Radiano.
That's all I know.
Or grout.
I also know más o menos. That's one of my favorite ones.
It's definitely Spanish.
En el ciudad or en el campo. I'm throwing every Spanish phrase out there I know.
2.03. How's that?
What did we get? 2.37. 2.037. What's after 7? I'm going to.
It's on the paper.
What is it?
Fancy. It's.
Oh, sweet.
Okay.
This is one of them. So, remember, I just took inverse cosine of a ratio. Well, inverse cosine is only defined for quadrants 1 and 2. It's not 1 and 4, it's positive in 1 and 4. Which means I have to get a positive and a negative to make it 1 to 1 to restrict the domain. So this answer must be in quadrant 2. How do I know it's in quadrant 2? Because the ratio was negative. But knowing what we know, I have to find everywhere that this ratio could exist. So where else would cosine be negative? That would be in the third quadrant. So this is the second quadrant answer, and I need to find the third quadrant answer. Does that make good sense? We just found 2 quadrant answers on the last one. There's always going to be at least 2 quadrants that it exists. So, really,
But why 2 and 3?
because
Why, I thought you just said we need a positive and a negative 2.
that's where inverse cosine is defined. Inverse cosine is only defined for quadrants 1 and 2. That's last unit. I did a whole big spiel why. Inverse sine is 1 and 4. Inverse cosine is 1 and 2.
Inverse.
Tangent is 1 and 4. Inverse cotangent is 1 and 2. Inverse secant is 1 and 2. Inverse cosecant is 1 and 4. We had to restrict the domain so there's only one possible answer in each of those. But in reality, there were 2 answers. And so if I have to give every answer between 0 and 2 pi, your calculator will only spit out one of them if I use an inverse trig function. Because that's all it's defined for. And I have to use logic, reasoning, thinking to find the second one. So in this case, the second answer is in quadrant 3. Because that's where cosine is negative. So, really what I need to know is, what's the reference angle? Well, this is ugly, right? Normally we've been dealing with angles that we know. I don't know that angle. That's an ugly angle. But I can find its reference angle. What do I know about this angle? I know it's in quadrant 2. I know what? I know in total I have rotated 2.038 radians. It's not in terms of pi, but it's still what it is. It's 2.03 radians. So what would be my reference angle? If I rotated from here to here, how much did I rotate?
Oh,
I rotated pi.
pi minus 2.
Well, I've already rotated part of pi. I've rotated 2.038. So to find this portion, it would be pi minus 2.038. Would give me that reference angle.
1.104.
So the reference angle is 1.104. So now I need that same reference angle in quadrant 3. How could I get there?
Plus that.
Pi plus that. Pi plus 1.104. Because pi gets me to here, and I need to go another 1.104.
4.245.
So the only time we have to do all that funny business is when I get ratios that I'm not familiar with. So here we'll see if I get a ratio I'm unfamiliar with. When I say that, I mean something on the unit circle, right, that we should know. Right here, we're just going to solve this just like it was an algebraic expression, algebraic equation. And we want to find out, well, what's cosine of this angle having to be? So
Theta minus 3.
let's do some algebra. We would add 3 to both sides, which tells me 2 cosine theta equals negative 2. Now cosine of theta is being multiplied by 2, so I divide by 2. So cosine of theta equals negative 1. So well, you could, I don't have to. Right? If you don't know your unit circle, you're going to have to do the inverse. But I know my unit circle. And I know cosine is a ratio of the adjacent over hypotenuse. That doesn't make sense here because I rotated to an axis. This is one of my special cases. So,
If cosine equals negative
cosine is the x value.
It's in the second one.
So where do I rotate to get x is -1? I rotated 180 or pi, and that's the only answer. And again, if you didn't know, if you put in your calculator the inverse cosine of -1, it would give you 3.14159265. Just pi. Here, I've got 2 sine squared minus 1 equals 0. Find all answers between 0 and 2 pi.
Divide by 2.
Not first. Add 1 first. 2 sine squared of theta equals 1. Now, divide by 2. So sine squared equals 1/2. Had to get rid of a squared. So sine of theta equals. I chose to take a square root. What has to happen when I choose to take a square root? Plus or minus? Right, every time. Have I not said that in here? I've said that a bunch. Every time. Thanks. I'm like a robot. The square root of 1. 1. The square root of 2. Radical 2. Is this a ratio you're familiar with? Not really, but maybe if I rationalize the denominator, if I multiply by radical 2 on top and bottom, then this becomes plus or minus radical 2 over 2. I do know that ratio. So where the opposite is radical 2 and the hypotenuse is 2, this is a 45, 45, 90. And because I'm looking for the plus or minus, where can I get this positive or negative? In all 4 quadrants, right? So there's going to be 4 answers here. 45-degree reference angle in each quadrant, which would be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
That's all of the thoughts.
That's all of them. Between 0 and 2 pi.
Richie responded to body vision yesterday.
Everybody good with that? All right. I look at the next one, and it says, find all solutions. Find all solutions. So this one is not going to be just 2 answers. It's going to be the plus 2k pi. 2 pi k, 2k pi. I'm finally rearranging it to 2k pi because it's just easier to say than 2 pi k. I don't know why it's easier. It's just maybe it's because what I'm familiar with. It's just like, have you ever thought about, like, I go through sometimes and I say like different couples' names that I know, like in the community. Like, do you ever like question why you say a certain person's name first in that couple's name? If you try to say it the other way, then you think it's odd. Like, I can't.
Yeah.
Which one? Which one's normal? Jack and Cam? That's what you say?
Yeah.
Like my parents, I think of them as Donald and Tracy, not Tracy and Donald. Greg and Sharon Wiggly, not Sharon and Greg. That's just the way it's normal. Huh? It's mom and dad? I agree. I don't know. So, hey, the reason I got there, like 2k pi or 2 pi k, just the order. Doesn't this the same thing? But I like the 2k pi better. Now y'all get to realize what goes on in my head that's just not healthy. So from here, I've got 2 cosine squared minus 3 cosine minus 5. I need to find all solutions. Does this remind you of anything?
Yes.
What does it remind you of?
One of those formulas that we
Yeah,
know.
I missed some of the-
Cosine minus cos. No.
Probably like the same.
No. Because this one's squared and this one's to the first.
Oh,
Right?
wait.
We're decreasing powers
It's
of
one of those
cosine.
things that make you grab you.
It reminds you of a quadratic.
Yeah.
Ax squared plus bx plus c. So how do we find the solutions? We could factor. We could do the quadratic formula. Please don't make me do the quadratic formula with that. Okay? But I would factor that. Now, the step I'm going to do is totally up to you if you want to do this or not. Some people feel more comfortable if they do a u substitution,
Wait, can
which
I not
means,
do it on both sides like the other one?
I guess, no,
Why?
because this is to the second and this is to the first. As soon as you start decreasing powers, like they won't combine, and then if I move that over, then I'm going to get an answer of cosine with cosine still on the other side. It doesn't work. So we have to factor. U substitution means, hey, everywhere that I see cosine of x, I'm going to write u instead. So this becomes 2u squared minus 3u minus 5. And then we can factor this. Because this, we just feel more comfortable with this. And then at the very end, once we get done, then we put cosine of x back where it's supposed to be. All right, that's a u substitution. So if I had to factor this, I would do the a times c method. 2 times 5 is 10. What multiplies to be 10, but combined is negative 3? That would be 2 times 5. I need a negative 5 and a positive 2. So this is 2u squared minus 5u plus 2u minus 5. Can I go fast? Or do I need to slow down right here? I've been doing algebra 1, so this is what I'm teaching them right now. So I may explain this too easily like your little kids. But I'll go over if I need to.
Why is the plus one here out of thin air?
It doesn't.
That's the GCF.
Oh,
That's how you factor doing the a times c
You
method.
can't take anything else
The
out.
GCF is 1, so I factor a 1 out. Because you have to have something in front of your parentheses to do a times c factor by grouping.
Okay, that makes sense.
If you don't know the a times c method, you must not have had me for algebra 1.
No.
If you did have me for algebra 1 and you don't know the a times c method, shame, shame, shame.
I never took algebra.
Shame.
Yeah, you did.
I never show my algebra 1 students the factoring by sight because they need to learn the methodology because they can't do like, you guys probably could do this one by sight, right? You'd have to do a times c. Maybe you can.
Wait,
I don't know.
is algebra 1 like what you take in 7th or 8th grade?
If you do the advanced, they will give you credit for algebra 1, which is a shame. It's a crying shame that they do that. But so from here, sorry, I don't know where I got to. We are multiplying two things to give us 0. This is one maybe you haven't heard me say. Maybe you have, I don't know. We multiply two things to be 0. That means either the first thing is 0 or the second thing is 0. I said a lot in algebra 1. I haven't got to yet. It's coming because we just learned factoring. So now I've got two equations with just cosine of x. So let's find our answers. So I'm just sliding this up, get out of the way. Let's start with the one that we like best first. This means cosine of x must be -1, which we just had this, right? This is a special case. Cosine is the x value on the unit circle. Where's my x value? -1. It's at pi. But I have to give every possible solution. So how often could I get this answer? Every 2k pi. So it's pi plus 2k pi, where k is any integer. Right, so we could rotate the negative direction as well, as long as k is an integer. Pi plus 2k pi for any integer k. And why am I having to do this with the k, the weird stuff? Because it says every solution. It didn't restrict me from 0 to 2 pi. Now looking here, I get 2 cosine of x equals 5, divide by 2. Now I get cosine of x equals 5 halves. Is that a ratio you're familiar with? No, so what would I need to do to find inverse cosine of both sides? And then once you do that, then we'll have a discussion. We'll have a little talk. Because I don't know if you're going to like what you see. Why? How did I know that? I didn't even have a calculator. I did that without a calculator. How could I have known that it wasn't going to exist?
Okay, so basically, when you do functions, sometimes one of them is a not real answer.
Yeah, that's not. Sometimes it can be. Higher than 1. Cosine oscillates between -1 and 1. 5 halves is 2.5. So where can I get 2.5? Another way you can think about it, this is a ratio of the adjacent over the hypotenuse. What right triangle do you know that has an adjacent side of 5 and its hypotenuse is smaller? It's 2. Can't happen.
So the answer is D and E.
For that one, it's D and E. So the only one that works is this one. This piece gives me no additional solution.
It is a solution, but it's not a real answer. It doesn't work.
This is the factored form, but I can't get any factors. If you think back to Algebra 1, which I know all you skipped, the whole point of factoring is to find x-intercepts. So if something factored to be right, say this was my factored form. What I'm doing when I solve is I'm finding the x-intercepts. So where would the x-intercepts be? At -2 and at square root of -4. What times itself is -4? You're going to go that route, it's 2i. But are these x-intercepts? No, these are imaginary roots. This is where it doesn't actually cross the x-axis. We did this in pre-cal.
Exactly, so it's not a real answer.
I didn't say it was real. You said the way you worded it was wrong. It's still part of the factored form, but it doesn't give me any additional x-intercepts. This is the only x-intercept. But all of these are the roots. So this is still a factor, but this factor produces no additional solutions. Just like this factor produced no additional x-intercepts. It doesn't matter. All you need to know is nothing came from it. I'm just, okay. Just move on. They don't care. They just want to get the canvas right. Okay. Yeah, exactly. I have no idea what he just said. Perfect. All right, let's look at this one. Solve for all exact solutions between 0 and 2 pi. List your answers separated by commas. If it has no solution, enter D and E. We're getting into, I could make a mistake at any point along here. I think I know what to do here. But I could go off the rails real fast. How can I solve this? Can I combine these?
No.
Why?
The argument is different.
That's right. In order to combine these, they're both cosine to the first, I would need to have the same argument, the same angle, which I don't have, so they won't just combine. I don't like that they have different arguments. I don't like it. I want to make them, change it. I want to make them the same. How can I make them the same?
Find one of them formulas.
Yeah, look at an identity we've done in the past. Maybe a double angle identity. How can I rewrite cosine of 2x?
I wish you could just do
Double angle identity, section 3. There's 3 of them. And remember, you're going to be given all these on your test. So you can go flip around to find them. But I'm thinking, I want to get rid of that cosine of 2x. I think it's section 3. There are 3 different formulas for cosine of 2x. There's cosine squared minus sine squared, right? 1 minus 2 sine squared. Which one do you think we should use here? Why? Right.
I can't find it. Which one is it?
Tell them what page you're on. Section 3,
Page 2 of 8.
page 2 of section 3. So like you're
That's
very...
why, because I don't have that.
Yeah. See if I can find it for you. You can wad it up and throw it.
Page 4. Oh, is it a double angle formula?
It is. And remind me, was it 2 cosine squared minus 1?
Yeah.
We're going to substitute that in. The reason we chose that was because now that it looks like something I can factor slightly, right? It's giving me that quadratic vibe. Ax squared. Now, this needs to flip, right? This needs to be my bx plus c. So I'm going to rearrange this to cosine squared of x minus cosine of x minus 1 equals 0. U substitution. U equals cosine of x. So I've got 2u squared minus u minus 1 equals 0. A times c method is 2. What multiplies to be 2 but combined is negative 1? 2 and 1. I'm going to write this as minus 2u plus 1 minus 1. Am I going too fast?
Nope.
Stop me at any point. Last year, they did not care to stop me. You guys never stop me. Grouping, I forgot the x, or the u, sorry. This would be 2u is the GCF, leaving me with u minus 1. GCF here is plus 1, leaving me with u minus 1. Meaning this factors to be 2u plus 1 times u minus 1, which I'm just going to go beside it because I'm also out of space. Which means I've got 2 cosine x plus 1 times cosine x minus 1 equals 0.
Wait, I have a question. How did you get negative 2 and negative 1 as the factors? Wouldn't that be negative 2 and positive 1?
Yes, it should have been negative 2, positive 1. That's a positive. I just wrote over the... Is that what you're asking me?
Yeah.
This is a positive.
Okay.
I put my parenthesis over the plus. That made it look like a minus.
What goes?
This is plus 1u. And this minus 1 was left over.
So it goes in the thing with it? Yeah.
Yes. The sign. The sign should be in parentheses. And then I factored the 1 out. I did a bad job writing. Two things multiply to be 0, so either the first thing is 0 or the second thing is 0. Let's pick the one on the right first. That tells me cosine of x must be 1. That's a special case. Means I've rotated nowhere. It doesn't tell me to give all solutions, does it? I think it says between 0 and 2 pi. So that means this is it for that piece. And now the left side. This says 2 cosine of x equals negative 1, which means cosine of x equals negative 1/2. That's a ratio I'm familiar with. So, two things I'm thinking. Cosine is adjacent over hypotenuse. So what's the angle where the adjacent side is 1? It's a 60-degree reference angle. So I'm looking for 60 degrees. Where? So because my ratio is negative, all students take calculus and I'm looking at cosine, I need it to be in the second and the third. So I'm looking for a 60-degree reference angle in the second and the third quadrants, which would be 2 pi over 3 and 4 pi over 3. Back to radians. Hopefully y'all are fluent enough to do. My brain thinks about the triangles in degrees, and then I just convert to radians. But you may need to stay all in degrees and then convert. Whatever. I told you, y'all gotta know that stuff. It doesn't go away. Hey, did I mention that unit 1 was really important? Did I mention that? Okay, I'll just make sure. What?
Sine is easier than cosine.
Why? I'm gonna get done. Dang it. No. Never.
Never back down, never what?
Never give up. Yeah. I'm going to explain this. I know that y'all can. Yeah, that's a 6. Okay. So I divide it by 2 radical 3, right? On both sides. Well, I don't like this radical 3 in the denominator. It's creeping me out. It's creeping me out. Yeah, it's creeping me out. So I multiply by radical 3 on top and bottom. 3 times radical 3 is 3 radical 3. Radical 3 times radical 3 is 3 times 2, 6. 3 over 6 reduces to 1/2. I like that ratio better.
Yeah.
So, you got options. There's options. I wish I knew how Northeast did it. I would not use my half angle formula because I don't like it. But you could, right? This is exactly what the half angle formula looks like from section 4. No, section 3. Second part of section 3. Plus or minus square root 1 minus cosine x over.
Okay.
You don't see the half angle?
How do you get the radical on the top?
Huh?
How do you get the radical on the top?
I'll move way past that.
I know.
I multiply by radical 3 on top and bottom. Of my ratio.
So
Because radical 3 over radical 3 is just 1. So multiplying by 1 didn't change anything. I just changed the form.
so if you multiply by radical 3 on bottom and top. So that cancels the radical 3. That makes the radical 3 3. And then it just adds
Times 2.
no to the denominator. It just adds radical 3.
No, that was already there. I divided by 2 radical 3 to start with.
No, to the numerator.
Yes.
It adds.
So they get multiplied.
Yeah,
3 times
there
radical
you go.
3 is 3 radical 3. You're saying denominator and then add, and I didn't like it. Okay, so I'm not going to use that formula. I'll watch the video to see if they do it. But let me just explain real quickly how I do this without the formula. I just ignore the over 2. Just ignore it for now. And this is some angle. What angle gives me sine of radical 3 over 2? 60-degree reference angle. And because it's positive, all students take calculus. I'm in quadrants 1 and 2. So to get 60-degree reference angles in the first quadrant, that would be pi over 3 and 2 pi over 3. Hold on, I'm not done. Hold on. Where am I? What page am I on? 5. Only between 0 and 2 pi. That's what I need to look. So, what am I doing with these angles? I want this whole thing to be pi over 3. Right? This should be pi over 3. Because sine of pi over 3 is this. You with me? So I need x over 2 to be pi over 3.
So it'd be
Which means 2 pi over 3 is this answer. And I want x over 2 to be 2 pi over 3. Because this should be the other answer. So my answer is 2 pi over 3 and 4 pi over 3. Because if I rotate to 2 pi over 3 and then half it, that puts me at pi over 3. And if I rotate to 4 pi over 3 and half it, that puts me at 2 pi over 3, which are the two answers I want. You know that unit 1 that you just finished? Probably wasn't smart you chat GPT'd all those. You probably need to, I don't know if you did, I'm just giving you a hard time. But you got to really understand the unit circle. I mean, really get it. But I mean, really understand. And I mean, really, like in your core, that's who you are. You are the unit circle. And it's so different, ain't it? That there's so many different ways you can really approach trig to start learning it. And so you're sitting under my leadership. I'm like your Aristotle. And you have to think about it the way I think about it. Whereas if you learn trig from a different teacher, they may not do all the triangles in the quadrants.
Yeah, they're not triangle people.
Right, they may not be. They could be a unit circle person. Or there's probably other ways that I don't know. But those are the two I'm familiar with.
The unit circle people, they suck.
It's like, did you know 2 people created calculus at the same time, independent of each other? Like they were both doing different things. So depending on which one you learn from, they approach calculus a slightly different way. It's Leibniz and Newton. And they both used it, but they learned it independently. Because it was... I'm not Newton or Leibniz. I'll be Aristotle. Yes. I've taught section 3 and 4. We also took the 3A test. Shut your mouth. That's the reason because we got 3 and 2.
It's the girl. What's her name? It sticks in here.
Some of those canvases. Then we worked on them here when y'all weren't here. That's where you did focus all of goes on the thing I'm teaching now goes on the next one. Really want to 3.1, 3.2 done, and then we work on the... Yeah, good one.
Brown.
That's what I'm making. So inside the forward, you don't have to need extra help with me. What do you have 7 periods on? 7. So any day you can stay in here. I'm free. Like I can sit down and teach you whatever. Because I know you're not really. You're going across country, but you're not really. Yeah. You know what I'm saying? So, I'm not saying every day, but I'll only be here. Where's the other part of it? I'll only be here today and tomorrow. 7th period. And I'm leaving Tuesday, 7th period. We'll have a little bit of grace period. My grades will probably be due here in a year. And so we've got a little bit of wiggle room. But we can get it done by here.
I'm so confused trying to figure out what this is.
It's trig. You don't try to figure it out. Solve for all solutions between 0 and 2 pi for secant of x over 2 So we're looking for where secant of x over 2 equals cosine of x over 2.
Secant equals x.
Secant and cosine are reciprocal.
Secant and cosine are reciprocals. Very good.
So it's probably going to be like a cross.
So where would a reciprocal be the same thing as the original? What's the number you can flip and it's the same thing?
0.
11.
Flipping 0 is not the same thing.
11.
0 over 1 is not the same thing as 1 over 0.
11.
This is 0, this is undefined, so that doesn't work. 1. If you flip 1 over 1, it's still 1 over 1.
I think that's all.
Negative 1.
Or you could just flip 11.
Or negative 1
It's
over
still
1.
11.
Right? If I flip negative 1, it's still negative 1. If I flip 1, it's still 1. So because they're reciprocals, I'm looking for where I get either a 1 or a negative 1. Well, where do I rotate to get 1 or negative 1?
180 degrees.
I rotate to an axis. Right? To an axis. So it could be, I just got to think here for a second. So we're looking at cosine. Sine is the y value. Cosine is the x value. So I'm looking for where the x values are 1 or negative 1. Well, that would be here and here. Right, those are the two places I'm at 1 and negative 1 on the x-axis. So how much did I rotate to get there? I rotated, we're in radians, so 0 or pi. But those are not my answers. Those are not my answers. Because I need this angle to be 0. And I need this angle to be pi. But this angle is x over 2. So I need x over 2 to be pi. Which means what does x need to be? That's it. Times 2 times 2. So x equals 2 pi. But this is not a valid answer. Because we're only going from 0 included to 2 pi not included. So 2 pi is not an answer here because we go all the way up to 2 pi, but don't include 2 pi. Right? Because parentheses, not bracket. So then that leaves me with 0. So I need x over 2 to be 0 times 2. There's my solution.
Yay.
Single solution.
So that is your solution.
0 is the solution. That's the final answer. This was all my thought experiment to figure out how much I needed to rotate. Then I had to take that information back to here.
So
Is there several different ways to think about this? Probably. But this is, again, this is my interpretation. That's why I want to watch the video, see how they do it.
Or teacher's way.
That's right.
Use our instructions.
Yeah, you have it with the course instructor.
You take it up with Pythagoras. Did I take it that far in this class? I did in my last class. I did a solve. Radical 3 cosecant of x equals 2. Divide by radical 3. Cosecant of x equals 2 over radical 3. And we're looking between 0 and 2 pi. I forgot to write that down. All right, this looks like a good ratio for me, but I got to think of what it is. Cosecant's the reciprocal of sine. Sine is the opposite over hypotenuse. So this is the hypotenuse over the opposite. So then I'm thinking, what's the angle that has opposite of radical 3, hypotenuse of 2? 60-degree reference angle. So I need 60 degrees, and I need it to be positive. So because this is the reciprocal of sine, all students take calculus. It could be in the first and second quadrant. That's my two answers. 60 degrees in the first quadrant, 60 degrees in the second quadrant. Well, 60 degrees in the first quadrant is pi over 3. 60 degrees in the second quadrant is 2 pi over 3. There's probably a better way to do this than what I've just thought of. But I'm gonna go with it. So I'm just gonna pretend like that this is just pretend like this is x for a second. All right, that's x. Tangent of x equals 1. So then I'm just thinking, where is my real angle if this was tangent of x equals 1? If this is 1, this is 1 over 1, right? And this is the opposite over the adjacent. So where is my opposite and adjacent the same?
45 degrees.
45 degrees. So I'm thinking 45, 45, 90 triangles. So I need 45 degrees, and it needs to be positive 1. So where is tangent positive? All students take calculus. I'm in the first and the third. So where would a 45 degree reference angle be in the first and the third quadrants? 45 or pi over 4 and 5 pi over 4, right? I'm going back to radians because my answer needs to be in radians. So this is what I want x to be.
So just making an equation.
But it's not an x.
Theta
Right.
minus
Exactly.
theta minus pi.
So I need theta minus pi over 2. Oh gosh, this is not going to work great. Y'all going to hate me. We'll figure it out. Theta minus pi over 2 equals pi over 4. Oh, it's actually going to be okay. You're not going to hate me as much as I thought it was going to be. If I solve for theta, theta equals pi over 4 plus pi over 2, which is,
Wait, why is it plus? I thought
it was a minus here, and I need to solve for theta. So I would add pi over 2 to both sides. Or for me, I moved this to the other side and make it positive. I went to the school of MacFall. That's the way he taught us. So that's my... Isn't it crazy that like your middle school math teacher that teaches you how to solve equations, that's the way you solve equations for the rest of your school career? It's like my 8th grade teacher, he was not a add it to both sides or subtract to both sides. He moved it over and changed its sign. So all the way up through high school, all my teachers had to do this. Move and change, move and change. They didn't add to both sides, subtract to both sides. Anyways, strange. I also need 5 pi over 4 as an answer. So theta minus pi over 2 has to equal 5 pi over 4. Move this over, change its sign. Theta equals pi over 2 plus 5 pi over 4, which would be 7 pi over 4. And both of these are still valid because they are still between 0 and 2 pi. Thank goodness. That's what I thought. I thought it was fixing to get real ugly.
Or the next one.
Yeah. I don't like this already. All right. Oh gosh, this scares me. I'm so nervous looking. I'm going to distribute. Don't know if that's what I'm supposed to do. That's what I'm going to do. 2 times tangent of x plus 6 equals 5 plus tangent of x. Okay, that's going to be okay. That's going to be okay. I'm going to move this over here, and I'm going to move this over here. 2 tangent of x minus tangent of x equals 5 minus 6. That's just tangent of x equals -1. No, it wasn't. I was afraid my tangents were fixing to cancel out, and that's going to be like the... It didn't happen because of the 2. I didn't fully process. That's right, distribute. Just trust the process. Okay. So, all students take calculus. I need this to be negative. That means I'm in second or fourth. And it's 1. So this is the same thing I just had, right? Opposite is 1, adjacent is 1. That's a 45 degree reference angle. But now I need 45 degrees in the second and the fourth, which would be 3 pi over 4, 7 pi over 4. And I don't have to move them. Because it's already an x in the argument. So
How
that's
do we know it's 45 degrees?
because it's 1 over 1.
Opposite over adjacent.
So this is where I know my special right triangles. 45, 45, 90 is 1, 1, radical 2. Or radical 2, and 2.
Like the other one was,
So I picked this one.
like the problem above that though.
I would not write down what I'm fixing to write down. Because
It's the last problem.
I do not, like, I've never seen a problem like this before.
Oh. You know,
I'm definitely doing a double angle identity. That's what I think. But I don't know if I need to do it with both of them or just one of them but that's where I'm going. So because these are double angle, but this also, exactly. That's my point. Because this is also cosine, cosine plus sine, sine, which means I could write it as cosine of, I don't know which way to go. Don't write this down. All right? Just think with me for a second. This reminds me, I think I like this one better than my first thought. This reminds me of cosine alpha, cosine beta, plus sine alpha, sine beta, which is cosine of alpha minus beta. That's the sum and difference. I put 2 equal sign. Sum and difference formula. So I'm going to work that backwards, I think. That's what I'm going to go with. So this is my alpha, this is my beta, so this would be cosine of x minus 2x. Well, cosine of x minus 2x is negative x. Oh, gosh. But even odd identity. If I have a negative in the argument of cosine, it just drops it. So this is the same thing as cosine of x. This is going to work out great. Cosine of x equals radical 3 over 2. What a pick, Cody. You did it. Do y'all follow those steps? That's the hard part of this one. It's what I just got done doing. Because now then it becomes just like the other ones. Are there any questions? I mean, that was tough. Like, I'm not...
Wait, is that solved fully?
No, I got to find x. But I'm just saying... Any questions what I've done so far? Because from here it gets easy. Like, I don't know why I knew to pick that. It just came to me. I was originally thinking write this as 2 sine cosine. Right? Using the double angle identity. And then I was also going to do a double angle identity here. But there were 3 to choose from. And I didn't know which one to choose from. And I was like, I was thinking it's going to get really ugly really fast. So then I just looked at the whole thing again and said, do I see anything that like starts triggering alarms? And that's what I saw. How did I know to do that? I don't know. But again, it goes back to when we first started these kind of problems. The biggest mistake people make is they don't try anything. They just stare at it. I'll try something, and if it doesn't work, or if I start making it look worse, I just scratch it and go back, or scrap it and go back to the beginning, right?
Is the answer 60 degrees?
It is not 60 degrees.
It's 30 degrees.
It's 30 degrees because cosine is the adjacent over the hypotenuse. So that means my adjacent side is radical 3. My hypotenuse is 2, which means adjacent is, this is a 30-degree angle. Correct, it's cosine. All right, and also because it's positive, I'm in the first and the fourth quadrant, so I need 30 degrees in the first and the fourth, which is pi over 6, and 11 pi over 6, 330.
Because you don't go from...
It always goes to the nearest x-axis. What a problem. I'm so proud of myself. Y'all just don't even... Okay. You know the one I was talking about earlier that was out of range originally but became in range later? This is going to be one. Okay? So just think with me for a second why I'm going to have more answers than I normally do. what does this, think about our transformations of graphs. What does this 2 do to my graph, to my cosine function? It changes the period. And so what would the period be now? It would be pi. 2 pi over 2, which is pi. Which means, what's the period? How quickly it repeats itself. So normally, cosine starts up here, and it repeats itself between 0 and 2 pi. But now it repeats itself in pi, which means from 0 to 2 pi, it makes its rotation twice. So if I'm looking for, and I'm just making this up, if I'm looking for where I'm at 1/2, now there's going to be 1, 2, 3, 4 places. It's at 1/2, between 0 and 2 pi.
Wait, can you draw out all of the problems like that?
Good if you want to approach it from that direction, but
I
that's,
think it would make it easier.
but you can go for it, buddy. It's not. Yeah, I mean, it all fits together. I just use this as a teaching, as a why this is happening. So, I'm expecting 4 answers going into this. So, again, just pretend like I just ignore that 2 in there originally. I just find theta. So, where's cosine of theta 1/2? Well, I need it to be positive. All students take calculus. So, I'm going to be in quadrants 1 and 4. It would not be 45. It would be a 60-degree reference angle. 60-degree reference angle. Which means I need 60 degrees in the first and fourth quadrant. Pi over 3. 5 pi over 3. Those are my 2 original instances. But now think about what's really happening. This is what theta was equal to. So I need 2x to be equal to pi over 3. Which means I divide by 2, which same thing as multiplying by the reciprocal, which means x needs to be so to make that angle be pi over 3, I need to plug in pi over 6. Because then I'm going to double it.
I had to double it.
Whatever. And so same thing here. Divide by 2, multiply by 1/2. Which now gives me 5 pi over 6. And now if you think about it, I'm not even halfway done rotating at this point. Right? Because pi is halfway. That's where the next 2 answers come from. So, really I need to think about pi over 3. When would I get back to pi over 3? I would get back here if I went another 2 pi around, which is 6 pi over 6, which would be 7 pi over 6 would also be a correct answer. We just normally don't use it because it's outside of this, what's the word? Domain.
Wait, how is it outside that domain?
Because this, oh, it's not 6. I'm an idiot.
It's less than
I'm an idiot. I'm an idiot. 7 pi over 3. Does that everybody feel better about that? Thanks for calling me out. We would have just went down. Now, I need this to be 7 pi over 3. Which gives me x equals 7 pi over.
Hold on, how did you get the 7 pi over 3?
remember yesterday the whole business with the 2k pi, 2 pi k. And there's an infinite number of answers. So the next time, like these are my two answers. But then I could also add 2k pi as many times as I wanted to. So I just did another 2 pi around from this one. And that gave me pi over 3 plus 2 pi. 2 pi is 6 pi over 3. So pi over 3 plus 6 pi over 3 is... I'm going to do the same thing with this one. Right? And the reason I need to look for the next ones is because of this period change. Right? It's happening twice as quickly.
So the next one's 11. 6.
The next one would be, we start with 5 pi over 3 and we add 2 pi. So 2 pi would be 6 pi over 3, which gives me 11 pi over 3. So I need this to be 11 pi over 3. So 2x equals 11 pi over 3. Divide by 2, multiply by a half. So x equals 11 pi over 6.
So now I can do it twice.
Which is still inside the range of 0 to 2 pi. And there's my 4 solutions. So right here I'm adding in the argument. So this is my alpha, this is my beta. So I'm going to use the sum and difference formula. So sine of alpha plus beta. This is sine alpha cosine beta plus sine beta cosine alpha.
It's so much easier to do your work.
It's probably about the same. It's just
No.
different.
I know what these two things are. They can simplify. So cosine of 3 pi over 4 puts me in the second quadrant, 45-degree reference angle. All students, that means this is going to be negative adjacent over hypotenuse. That's what this one is, negative radical 2 over 2.
But it's in the second.
If it's in the second quadrant, it's negative. Yeah, I didn't write. I said it, I didn't write it. All students makes cosine negative. And now the same angle, but now find sine of it. Well, it's going to be positive.
It's at like 9 a.m. We should make a petition for prom to be at 9 a.m. Make sure.
I would like that better.
So I think the answer is going to be this.
It's just that.
I think it's negative radical 2 over 2 sine x plus radical 2 over 2. Yeah, I don't know what else to do from there. I could factor a radical 2 over 2 out, but I don't. It's not going to be helpful.
Sine plus
It's a strange one.
radical 2 over 2. So sine
Mhm.
is just that.
I think so. See, click the answer. See if that's exactly what they. Yeah, okay. You know, sometimes it'll accept a different form. Yep. So I'm just making sure.
Part of me's gone.
Those groups, like I can do the fucking, I don't like these.
What is this thing?
This is the safe set. I can do almost everything else.
Oh, I didn't set it.
Did the wrong formula.
Yeah, I did cosine and sine.
So that's you try it from there. That's probably what it is. Just when I start thinking, go away. When I start thinking about this, everything being not in terms of sine and cosine, I think I want to put them all in terms of sine and cosine. I don't have any reason why other than just because they're not even, that's just what I'm thinking. So, 1 over cosine minus cosine over 1. I just went ahead and put that as a fraction because over sine over cosine. All right, and then this is a very common thing. Up here, I'm subtracting fractions in the numerator. So to subtract fractions, I need a common denominator. So the common denominator would be cosine. So I'm going to multiply this second one by cosine on top and bottom. Now I've got 1 minus cosine squared over cosine over sine over cosine. Do that? Now, this screams at me. Pythagorean identity. That's sine squared. So I'm going to rewrite this as sine squared over cosine. And I'm going to write the second part like I'm a 5th grader. Right? Now it's divided by sine over cosine. KFC, whatever the junk y'all want to say. And now I can start cross-reducing. Cosines cancel. One of the sines cancel. Leaves me with sine of t. Cosine one just completely gets dropped.
Sine, it goes out.
Sine, it comes outside.
And cotangent also goes outside.
That's right. And so now then, look at your fraction. It's a negative over a negative.
That's positive.
That's right. So now I've got cosine of x plus sine over cotangent. This is a loaded garbage junk. So I want to just focus here and fix that.
Put that sine over cosine over sine.
Sine, and I'm going to put sine over 1, over cosine over sine, which is sine over 1 times sine over cosine, which would be sine squared over cosine. So this here I can write as sine squared over cosine plus cosine over 1. Now I'm adding fractions. So I want to get a common denominator.
So multiply by cosine on.
So this becomes, that's right, cosine squared over cosine plus sine squared over cosine. Which means I could write this as sine squared plus cosine squared over cosine. Pythagorean identity. Sine squared plus cosine squared is 1 over cosine. Which means if I move cosine to the numerator, it becomes... Okay, this one. Yeah, sorry, I went too fast. Probably I didn't give you time to write.
No, it's okay. I understand it.
I'm with you. I would rather watch the whole thing and then go back and try to recreate it than try to copy as he's going.
It's not a valid fraction.
Two times 12.
I know this changes.
That one. I do, but I just don't like it.
And then this one, I don't know, it changes in like 10 squared x plus 1.
You've already found sine. Sine of the angle is...
Had to have high horsepower limit.
This whole thing it's not sine of 12. You take sines of angles to get ratios. This is just straight up. That's right. It's no longer in the sine cosine bondage or whatever you want to explain.
Can I come in during fifth period and make up that test?
Yes. Any period you can free to make up. And if you got questions, like I need to answer, this period's good.
I'll get Chris in.
Okay, that's fine.
Yeah.
He's a good one to ask.
And Brandon. I like Brandon.
Chris and Brandon are in my mission halls.
Okay, gotcha. Is Brandon nice to y'all?